Hello, hello, and welcome everybody. Hello, PLV. How are you doing? Hey. So yeah, today we're gonna be doing something different, something that I wanted to try for a long time. We're gonna try and see what's going on with Godot, and see if it's useful. Can we work with that, and how to work with that? And yeah, previously I was never working with Godot. I know almost nothing about it, except that it's open source. It's supposedly pretty good, and I want to try and make like a small side project, very small game using it, and see if I like it or not. And the goal, I guess, is to make it a web application so it can run directly in the browser, ideally. I've read a little bit about it, but let's take a look. Hopefully this is visible on stream. So the limitations are C# is not supported. And yeah, I know that C# is a weird topic on for Godot and for Unity as well. But at least in case of Godot, they're a little bit more progressive, like they're actually using new .NET Core. But for a web, it's not an option. Which is a bummer, but it's understandable. I would probably never use it for a project like I want to create right now. So we're gonna also learn GDScript, I guess. So yeah, where was the compatibility? Yeah, Forward Plus and Mobile are not supported on the web platform. So we're not using WebGPU, which is fine. Can I use WebGL 2.0? So yeah, that's the plan. We're gonna create a compatibility render mode project. And I have no idea how to name it. Because I have no idea yet what it's gonna be. Because it's just gonna be a bunch of experiments. Let's name it Magenta Fish, I guess. Hello, Aninia. How are you doing? And yeah, I'm probably gonna try and follow a YouTube tutorial. Let's see if that works. And yeah, this is gonna be a 2D game, and I'm gonna be using, at least for start, and I'm gonna be using some free assets. Haven't yet extracted them. 1 sec. So yeah, let's try to follow a video tutorial.
Open in file.
Which one was I working with? This one, I
Importing
guess.
assets in Godot is extremely simple. The file system window is where we have all the files we use in our game. By default, the only thing in here is the Godot icon. So let's create a folder where we can put our assets. Let's right-click, new folder, and name it assets. Let's also make one for scripts and scenes that we can use later. Now we can simply drag and drop our assets into the asset folder. So I'll select the assets folder, open up my assets here. I'm going to select all the subfolders and click and drag them into Godot. And voila! We can now see and use all of our assets in Godot. So now we're ready to make our game. So let's
Assets, right. Sorry for the delay, my internet connections, but no problem. You're just in time. We're just starting. So welcome.
talk about how we do that. To make anything in Godot, we use nodes. If we want to make a player character, we do so by putting together a bunch of nodes. If we want to make an enemy, we do so by putting together nodes. If we want to make a main menu, you guessed it, we use nodes. So nodes are the fundamental building blocks of your game. And nodes come in many types. Some display an image, others play a sound, or add physics. And we can even extend existing nodes to build more powerful ones. So in its essence, making a game in Godot is combining and extending nodes to get the result we're looking for. It's a super creative and fun process. But building everything in one big world with nodes for the player, enemies, UI, and a bunch of levels all in one place would quickly become completely unmanageable and confusing. Instead, we use scenes. Scenes allow us to bundle together nodes into reusable packages. A scene can be a character, a weapon, a menu. They can be as small as a single collectible coin or an entire level. Scenes make it really easy to focus on building one part of our game at a time, and then slowly combining them to make our game larger and larger.
So a scene is something like a bundle of nodes, I guess.
This is because we can put scenes inside of other scenes, which is called nesting, and allows us to take, say, a player scene, a platform scene, and a collectible coin scene, and put them all inside of another scene, say a level 1 scene. And even cooler, since scenes are reusable, we can make a scene only once and then use it all over our game. We can make many levels that all use the same collectible coin scene. And if we want to change something about our coin, we...
Oh, by the way, I forgot to change the title.
simply edit the scene and it automatically updates everywhere else. As you can see, all the nodes and scenes in our game start to resemble a tree-like structure. And that's exactly what we call it, the scene tree. And fittingly, we call the node at the very beginning of the tree the root. So now that we know a bit about how Godot works, let's start by making the most essential part of our game, the player character. Player 1.0. So let's create a scene where we'll put everything together. This is going to be a 2D game, so I'll select 2D scene. And let's rename this from Node 2D to Game. And even though it's empty, let's go ahead and save it. So hit Ctrl S, go under Scenes, and let's save it here. And now we can...
Okay. Okay. So what do we have here? Position. canvas item. Okay, so I have visibility layers, we have light masks. But yeah, it's not gonna be applicable to this particular scene, I guess. That is just the root. But I'm just looking what do we have here. Texture and material are different things. Interesting. I'm more used to Unreal materials, which can be textures themselves. But here we have two separate things. Interesting. Okay. Signals. Oh. Okay, let's get back to the
Actually
tutorial.
play our game. It's not going to be very exciting, but let's try it out. So let's hit play up here or simply press F5. It's going to tell us that we haven't selected a main scene. We need to tell Godot which scene to run. I'm just going to press select current, and you can see that our game scene becomes blue to let us know that this is now our main scene. And
Okay. We have some kind of toolbar here. I guess. Game speed. Pause. Reset. Huh. Interesting.
as you can see, not much is happening here. So let's stop playing by hitting the stop icon here or pressing F8. And let's put in a player to make it more exciting.
Can I press F8 to start? F5 to start. Perfect. Amazing shortcut. I like this shortcut.
So first off, let's create a new scene by hitting the plus sign up here. And this will be our player scene. And the root node for our player is going to be what is called a character body 2D. So let's add a new node by pressing the plus here or hitting Control A. And let's search for character body 2D.
Wait. Didn't press the 2D scene.
So let's stop playing by hitting the stop icon here or pressing F8. And let's put in a player to make it more exciting. So first off, let's create a new scene by hitting the plus sign up here. And this will be our player scene. And the root node for our player is going to be what is called a character body 2D.
Okay, so this creates a new scene and I can select one of these or...
So let's add a new node by pressing the plus here or hit...
is its own type, node type, I guess. What do we have? Window, pop-up. Not 2D and control. Oh, this is the UI stuff, I guess. Okay, interesting.
Hitting Control A, and let's search for character body 2D.
Right. Is there a difference if we create a root node or a child? Character body 2D. Guess that becomes the root node because there was no children. Yeah, okay, I see. Hello, 𝙽𝙴𝚁𝙂. How are you doing?
As you can see, this is a 2D physics body that is specialized for characters moved by script. So it's perfect for a player character that we want to be able to collide with the environment. So let's hit create. And now we can see our node here, but we can't actually see our player in the scene. So let's add some graphics. Let's add another node. I'm going to hit Control A and let's search for sprite. And as you can see, we can choose a single sprite, or in our case, we want to create an animated character. So let's choose the animated sprite 2D. Sprites are just what we call images in our 2D world.
You're fine. I'm good too. Yeah. Decided to do something new today and learn Godot, or at least take a look at it and decide if I like it or not, and see what can I use it for.
Now, with this node selected, we can use the inspector here on the right to change properties on that node. If we select a different node, say our character body 2D, we can now see the properties on that node instead. So our
Okay, so I have collision now, and the rest is the same, I guess.
inspector allows us to change things about a node.
Okay, so this is properties that come from hierarchy, I guess. So we have node, some basic node properties, right? Canvas item, node 2D extends the canvas item with its own properties, and animated sprite 2D. Okay, I like this.
In our animated sprite 2D.
So it's not like components in Unity, it's actual properties of a proper hierarchy, I guess.
We want to add some animations, and we want to give it some sprite frames, the individual frames that will make up our animation. So let's click here and add a new sprite frames. And now with this selected, we can see that it will open up the sprite frames window.
Was it drop down or yeah? What is that? Quick load. Okay. Huh.
Individual frames that will make up our animation. So let's click here and add a new sprite frames. And now with this selected, we can see that it will open up the sprite frames window at the bottom. And in this window, we're going to press this tiny icon here that lets us add frames from a sprite sheet. So let's click that, go into our assets, under our sprites, and let's find our 𝙽𝙀.png.
Okay, so I'm gonna use a free resource pack that I find interesting, which is this one. I'm gonna also put it into the chat, and also I'm gonna put the video link to the chat if you guys are interested. But yeah, I want something like a top-down 2D game, and like this color palette looks pretty good, looks nice. And the character is interesting. So let's try to import that into the game. So characters, right? For now, not gonna import everything, but I'm gonna create characters. Also, I don't really like lowercase names. This is much more readable. Okay, so characters. Let's import this thing.
And as you can see, I've gone ahead and packed all the different sprite frames of the knight's animation into a single image. This is called a sprite.
So what did
And in the selected, we can see that it will be icon.
Okay, add frames. Blah, 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 blah. Why is this became a scene? Okay. So back to our game. Wait. Oops. I closed this scene. Okay, now I understand. Made a mistake. I closed this scene that I didn't save yet with the character body and animated sprite. Okay. Sprite frames. Now we click here, assets, characters, and then this.
Here that lets us add frames from a sprite sheet. So let's click that, go into our assets, under our sprites, let's find our knight.png. And as you can see, I've gone ahead and packed all the different sprite frames of the knight's animation into a single image. This is called a sprite sheet. It's a very efficient way of working with lots of sprites, such as when doing animation. Otherwise, we would have to create an image for each single frame, which would quickly become an unmanageable amount of files. Now to start adding these frames in, we first need to configure the grid here. Currently it's set to 4 by 4. Let's go ahead and increase this. I've created an 8 by 8 grid here. And as you can see, each frame now has
We actually have a 4 by 4 grid here. Good.
its own grid cell. And let's just start by adding the idle animation. To do this, we simply click the frames in the order that we would like. So I'm going to go from the left-hand side here and click. As you can see, it says this to 0, the first frame. Then I'm going to click the next one and the next one and the next one. And now it goes from 0 to 3 and we'll play from left to right.
But how do we then switch to different ones? Add 4 frame. I see.
We can always click again to remove, and this is how you can quickly build an animation from different parts of your sprite sheet. So I'll select these 4 frames and hit Add Frames. Now let's hit F to center our character on the screen, and I'm going to use the scroll wheel to zoom in. We can also click and drag with the middle mouse frames and hit Add Frames. Now let's hit F to center our character on the screen.
Yep. Okay. I think this is a wrong animation. Maybe not. This doesn't look like an idle animation to me. One sec. Looks nothing like in the preview though. I guess this is supposed to be like a walking animation or something. Weird, really weird. Maybe I downloaded a run portion. Or maybe there's a part of the premium pack or something. I think this is idle. Just 2 frames. How do I delete this? Okay. Okay. Whatever. Yeah, I guess this is the idle animation. This is the walking animation. Okay, for now, that's gonna be enough. Why not?
And I'm going to use the scroll wheel to zoom in. We can also click and drag with the middle mouse button to pan. Now our character looks weirdly blurry. That's because we're working with pixel art, which requires really hard edges. By default, Godot is going to try to do some texture smoothing to make textures look better, but applied to pixel art, that is definitely not the case. So let's simply disable this. So let's go to Project, Project Settings. Let's go under Rendering to Textures. And here on the default texture filter, let's change this from linear to nearest.
Okay, linear to nearest. There we go.
Which will immediately make our pixel art look crisp. Then we can select our animated sprite. And let's try playing the animation. That looks great. I'm going to increase the FPS here to 10 to make it go a bit faster.
I need to make it actually slower. Something like that.
I'm also going to rename the animation here to idle. I'm going to enable autoplay to make sure it plays right when we start the game. And finally, I'm going
Where?
I'm going to enable autoplay to make sure it plays right when we start the game. And finally, I'm going to take the sprite here and move it up to make it kind of stand on this line. And that's it for our graphics for now. Now we'll add more animations later, but as you can see, we're currently getting this warning here in the scene view. And if I hover over it, it's going to say that this node has no shape.
Yeah.
So it can't collide or interact with other objects. And this is because a character body 2D is a physics node. And whenever we're working with physics, we need to define a shape that the physics engine can work with. So let's add a new node. I'm going to press the plus sign here. I'm going to search for collision shape 2D, hit create. And here in the inspector, we can now define a new shape. I'm going to add a circle shape. I'm going to make this a bit smaller and drag it up. Somewhere around there looks fine.
Why circle though?
Now you're probably thinking, well, this is pretty far from our actual graphics, but that's totally fine. Colliders rarely need to be very precise, and it's a good rule of thumb to make them a bit smaller than the graphics if you need to. Having colliders that are too large is simply going to be frustrating when playing. So let's now rename the top node here to...
But why circle? I guess... Okay, I think I understand. I've never worked with like 2D games. I guess circle sprite would be nice on corners, or nicer on corners. Not sure if I like it though. Capsule for this one, I think, would be better. But in this game, we don't actually need some sophisticated shapes, sophisticated collisions. I think this should be pretty good. We're only gonna have like walking, I guess.
Player. And let's save the scene, Control S, as player, hit save.
Player, right.
And now we can go into our game scene and simply drag our player in here. So I'm going to go to the top here and drag in the player. We also need to create a camera so that we can control what...
By the way, coordinates. Red, I guess, is X. But I can see, like, I'm not sure if it's possible to see it on stream, but there is like a faint blue shape, which I guess is the screen. So 0, 0 is top left, I guess.
What is currently being shown.
I just saw something. Okay, whatever.
So let's...
Wait, maybe it's Alt. Yeah, it's Alt, I see. So if I hold Alt, I can like get these, how is it called? Anchors or whatever.
Add a new node, hit Control A, search for camera 2D, hit create. And now if we press F, we can see that we have this huge camera viewport.
Wait, what's this then? This blue line.
This is definitely currently too large, so let's zoom in on our camera. I'm going to set the zoom here to 4x4 and simply click and drag our camera to be on top.
So zoom 4x4 is basically making one pixel appear as 4 on screen, I guess.
of the player. And now we can try playing our game. And there you go. We now have a player that is playing an idle animation and nothing else is happening.
Okay.
That's because we need to add a script that allows us to move around. So let's close our game, go into our player scene, and with our player node selected, let's press this Add Script button.
Oh, by the way, let's rename this to capital G game. So player script.
Here we can choose a template. Of course, we're going to do some programming in this video, but writing player movement can quickly become a bit overwhelming. So for now, we'll use the basic movement template provided by Godot. Then later, we'll go in and modify it to play different animations and rebind input to the keys we'd like to use. As for the path here, I'm going to make sure that we put this inside of our scripts folder, and let's just name it player. Let's say
well, I guess the default name convention for Godot is lowercase, but whatever. This is what I prefer.
create, and as you can see, this creates a script that will move around our character.
Okay. Can I adjust? By the way, where editor settings, there's what I'm looking for. Can I adjust the code text size? Main font size, code font size. What did I have in my VS Code for the stream? $16. Hope you guys can see it, but it actually looks smaller than in VS Code. Yeah, it is smaller. I guess the font itself is smaller. Can I change the font? Code font. What's the default? Should I do it like this one? Or should I just increase? Let's increase the size for now a little bit. That should be readable on stream. I hope. Let's go with this one for now. So what do we have? Speed, jump velocity. So minus 400, yeah, means Y up is Weird. Okay, whatever. We'll figure that out. Actually, I can easily see that, I think. Wait. How do I... Ah, that's script. So what are the coordinates? Transform. All right, so... Yeah, it's inverted coordinates, basically. Howdy. When trying to figure out what this Godot is about, how it works, and how to work with it. But yeah, looks like y coordinate goes negative. Well, no, I don't know how to describe it. It's basically inverted y-axis. So it goes from top down to bottom. So here we have 0. Here we have 90 something. This is why we have negative jump velocity, I guess. Yeah. Weird. I don't really like that, but I guess it is what it is. It's fine. And x is fine. Okay. Back to the tutorial.
I know that this might look really confusing at first, but don't worry, we'll have a look at what all this means later.
Doing the same. You can find a tutorial by Clear Code that expands on a lot of the concepts. Breakers guide is also a good starting point. Yeah, this guide, you mean? Yeah. So far I like it, but yeah, I just basically started. Like we are literally 40 minutes into Godot. I've never created a project in it. So yeah. A little platformer level. I'm not making a platformer, but so far I like how this guide describes everything. And I'm like experimental along the way, like trying to figure out the UI and how the engine works. Yeah. Clear code. Ultimate introduction. 11 hours and a half. I'm not ready for that for now. I need to be fairly intuitive for the most part. I couldn't get my head around Unity and Unreal. I'm very used to Unreal, but mostly to the older versions of Unreal. So like Unreal Tournament 2004 is what I'm the most comfortable with. But I am a little bit familiar with Unreal 5. That one is very intuitive for me. Godot is completely different. I will probably never use it for 3D, but I don't know, maybe if I like how it behaves in 2D, I'll experiment a little bit with 3D. Maybe I like it. So basically right now, I just want to familiarize myself with the engine, see how it works, if I like it or not, and what I can do with it.
For now, let's just try playing. And our player immediately falls off the screen.
Wait. Okay, so I created a script, yes.
Put to the key scripts folder. We'll move around our character. I know that this might look really confusing at first, but don't worry, we'll have a look at what all this means later. For now, let's just try playing.
Yeah, so we can just already try and play with this script. Nice, okay. So at least for now, we have consistent
results. And our player
results.
Immediately falls off the screen. That's because we need to give him a collider to stand on. Right now, our player
Platform,
has a collider, but it doesn't have anything to collide with. So in our game, I'm going to go back to the 2D view at the top here. This is where we can change from script view to 2D. Let's add a new node. So let's hit the plus sign. Let's add a static body 2D. And this is another type of physics body. It's the one we use for things that don't need to move. That's why it's called static. So it's perfect for creating some ground. Let's hit create. And again, this is going to give us this warning here that it needs a shape. So let's add a collision shape. So I'm going to hit Control A, search for collision shape. And for the shape here, we're going to create a new world boundary shape.
This is weird. I'm still not used to this like hierarchy. So instead of defining shape in the properties, we are creating a child node. Physics material. Allow me 2000 for XP aesthetics. Thank you. That's all the way down. Okay. I'm just trying to figure out the logic. Like, I like the inheritance system and the way the properties are displayed with it. So yeah, we have basically all the parents of this type, static body 2D, of each child. This is really cool. I like it. But I haven't figured out how the node tree works. Like, right now I'm trying to imagine how this static body 2D... Can I look at the script of it? No. Maybe I can, but I don't know how to do that. Basically, I'm trying to figure out how this thing knows about the children and makes them, like, close the collision from the children. But okay. Yeah, my scene is a node and I can drop anything inside it. Everything is scenes. Like, this is something that I can't comprehend. Like, what's the difference between a scene and a node? So you can scene while you scene. Yeah. Coming from Unreal World, scene is something that you can view. Like your main, like game view, for example, or your main menu, like a level, and you can put everything inside it. But here it's definitely something different because my player is a scene. And it is a node at the same time. So I don't know. Nodes make up scenes. Like your game is a scene, your player is a scene. Your scenes are made of nodes, but you can put scenes in other scenes. Okay. Well, okay. How do we need to add collision shape
and
to the...
a collision shape. So I'm going to hit Control A, search for collision shape. And for the shape here,
Control A to add a node, right? Yeah.
we're going to create a new world boundary shape. The world boundary is a type of collider that is perfect for stuff like, well, world boundaries, because it's going to extend infinitely on the horizontal axis here. So as you can see, it's currently pointing up. We could also point it to the side here, and now it's going to extend infinitely on the vertical. I'm going to hit Control Z to undo that. Instead, I'm going to select the entire static body here, I'm going to change to the Move tool by pressing this icon here or simply W on the keyboard. And I'm going to move it down under our character. Then I'm going to go back to our Select tool, which is here, or simply press Q.
Okay, hold boundary. So wait, where was it? Here. So right now it's in 0 coordinates, right? And my player is also in 0. Does it mean that my player will fall through it? No. But if I, wait, player, please. If I move player below that, I guess it pushes out the collision sphere. So here it theoretically should fall down? No. What? Do I need to save? Interesting. So is it treating everything below this as like end of world? I guess. Yeah, I guess that makes sense. As world boundary.
And while our collider doesn't have any graphics, it's going to be invisible, we can now play. And there we go. Our player now gently lands on the collider and we can move around using the
Interesting. Okay.
arrow keys and jump with the spacebar.
Now that's a high jump. Okay.
Now our player is currently a bit too fast and I think his jump is a bit too high, so let's modify our script to change that.
Yeah, I already wanted to do that a minute ago. So speed. I don't know. Something like that, probably. I would prefer to have some kind of acceleration, but yeah, I guess I need to cut it. Yeah, it's linear speed. Axis. Does it work with the controllers out of the box? I'm really curious. Let me take out my controller. Yeah, it does. Although I cannot jump. But yeah, D-pad works left to right, and the left stick works left to right, but I cannot jump, at least on my DualSense controller, which I guess is not standard for Windows. You can get to the top and look at the options to assign your keys. I mean here? Input map. No. Input devices, sensors. Guess there is some kind of default input map. Because here we have just UI left, UI right, UI accept. I don't see it here. Oh, show built-in actions. Aha. So if we do, how is it called? UI accept. Let's add new. Filter by name. Enter. KP, enter. What's that? KP, enter. Keyboard keys. I guess numlock enter. Let me double check that. Yeah, that's numlock enter. Numpad enter. Keypad, yeah. Ah, keypad, literally. Okay. I'm stupid. And space. So I guess, can I add... How do I add a new one here, I guess? JPad buttons. Aha! So it automatically maps different controller types and recognize Sony, Xbox, Nintendo. Great. Awesome. Amazing. So if we do that... There we go. Now I can jump by pressing X on my DualSense. Okay, I like it. I really like it. Also, you guys probably don't see it correctly. Can I do 2 times zoom? Oh, that's speed. That's speed. Can I scale this? Fixed size. I guess in the project settings I can define the viewport or window. Oops. Why is it this weird size? I guess it's supposed to be less than 1200. 648. Weird. I skipped something to create a new game in Godot. I'm trying to learn how to work with Godot on some like very small, simple project. And right now I'm just following a tutorial. But yeah, I'm trying to learn Godot and see if it's useful to me, if I like it or not. Okay, that's viewport. What I want is scale. There we go. 2 times, please. There we go. Also, I think this is more like... No. Okay, this is something that I shouldn't mess with right now. It's just the problem is I'm working on a 4K screen with scaling. So I need the integer scale because this is a pixel game. But I want the game To recognize my screen DPI. That's what I want. And this project should be AI and MCP. No. Stretch viewport, aspect, scale mount. Let's read the tooltips, I guess. Defines how the base size is stretched to fit the resolution of the window on screen. Disable no stretching happens. 1 unit in the scene corresponds to 1 pixel on the screen. In this mode, display window stretch aspect has no effect. Recommended for non-game applications. Canvas item, the base size specified in width and height in the project settings is stretched to cover the whole screen. The base size specified in width and height in the project settings is stretched to cover the whole screen. Aha, I think this is what I need. Oops. No. I have no idea. If you want the actual place size of your viewport to go bigger, just change the viewport width and height. The thing is, I want it to be, I want it to automatically scale with the screen DPI, ideally. I don't think it's possible out of the box. Probably I need to write a script for it. Okay, so if I don't change anything, click play. You're like, can I make it so it resizes with the window or something? Yeah, like the game itself, the viewport of the game doesn't resize when I resize the window. That's weird. Viewport. But that's what I need. Huh. Ah. Aha. So it's not the project settings that control that. It's this preview thing. No. Aha. Okay, now I see. Okay. So if we, what does viewport do? The size of the root viewport is set precisely to the base size specified to the project settings display section. I don't understand. This is what I want, but I want the window by default to be bigger, so I guess I just set it in the project settings to something like this. 2726. Wait, let me... I can just do 1440p resolution. And it should look nice on stream. So it's at 2560. Wait, let me Google that. Yeah, 2560 before 40. Nope. I have no idea. Maybe something like that, at least for now. Should look nice on stream. To me, it's a little bit bigger, but it's okay. What does this do? Yeah, I think this is what I want. Okay, for now this will do. And I guess we will need to add some kind of script to automatically adjust aspect ratio, not aspect ratio, but the zoom based on the screen DPI. Okay, for now it's fine. So let's get back to our tutorial.
Let's close our game, go into our...
I think the viewport is simulating a screen resolution for you. I don't know. Well, for now, this looks fine to me. Actually, maybe not. What if I move the player there and I cannot see it? Let's revert the zoom changes. So now, right now, this is on the side of the screen. Did it change when I changed the project settings? Yes, oh my. So changing the window size, viewport with height, changes the camera on the scene. That's a little bit ridiculous. And this is definitely not something that they want. I want to stretch viewport, I guess. Yeah. Now, I guess I need to find another settings like, how is it called? This debug view, how is it called? I need to change this window size to a different thing. What am I trying to do? I'm trying to make the window that appears when I click run bigger by default, as if I would resize it. So the game is bigger on stream while keeping the coordinates like they are. Because when I change the viewport size, Wait, what? If I change the viewport size, it changes the camera size on the scene. No, that's the thing. So right now, I have a scene where I placed the player at the very edge of the screen. If I run it here, it's at the very edge. Good. If I resize it right now, again, it's at the very edge. It's just stretched, which is exactly what I want. Now, if I change the viewport size to 1440p, you can see now the camera is bigger in the viewport. And if I run the project, the character is now here. So this is not what I want. I want the viewport stay the same, but the actual play window to be bigger. Like I guess maximizing it solves this problem, but I want it to start as like 1.5 size by default. Maybe it's here. Run out font size. I don't know. For now, it's okay. For now, it's okay. This will do. You can just maximize it and play it. Okay, let's get back to the tutorial.
Our script. And at the top here, there are two constants that we can modify, our speed as well as our jump velocity. So I'm going to set the speed to something less like 130 and the jump velocity to say -300. And now when we play...
By the way, our code is slightly different. I have get gravity instead of that thing.
It looks and feels a lot better. So our player is moving around, but currently there's not much to look at. So let's build a world to explore. World building 1.0. So to build our world, let's begin by removing our collider here. We're going to build an actual ground for him to stand on. And let's instead add a tile map node. So let's press new node and search for tile map. Now, the most common way to create levels in 2D is by using tiles. In other words, we build our game world by drawing different tiles onto a grid. This is a great way to work because we can create a lot of varied levels using just a few tiles. The tile assets we use to paint are normally packed together into one big image, just like our player was. This is called the tile set. So the tile set is a collection of tiles that we can use to paint from, and the tile map that we just created is the node we use to paint these tiles into our world. So to start painting on our tile map, we need to add a tile set. So in our inspector under tile set, we'll create a...
So this is gonna be slightly different from the tutorial because I'm not gonna do like side view platformer, but top-down world. So let's see. And basically this is why I wanted to try Godot specifically, because of the tile maps and the way it works with them. I really liked how that worked. So
new tile set. And if we press it here, we get to configure something.
Tile set. Tile sources. Patterns.
Things about it. The main thing you want to make sure is set correctly is the tile size. The tile set in our asset does indeed have 16 by 16 pixel tiles, so we'll just leave that as is.
Yeah, so in our free pack tiles, what's the size? Does it specify the size anywhere? If you want to do an ARPG like Legend of Zelda Link to the Past, you can find one from a guy called Heartbeast. I have another video open. This one, I think.
Manager. Now I'll create a new folder in here with right click, new folder, and I'm going to call this art. Let's enter into the folder. Going to minimize the Godot window here. And now let's double click on the zip. I'm going to right click on
Wait. This guy actually uses the same pack that I'm using. Okay. Clear Ghost has a Stardew Valley guide.
Copy where everything is created as an instance from. We can see in this
similar,
there's a node hierarchy. So scenes are composed of nodes.
But yeah, this guy uses the same tile set that I'm using right now. Oh, tile sets.
So at this point, we have a character that can move around, but there's really no game world for it to move around in. So let's add in a tile map. I'm going to right click on game level, and then I'm going to add a child node, search tile, and you'll find tile map here. So a tile map can draw on a bunch of tile objects from a tile set. So it's really handy for being able to build a map from basically an image sheet. So if I look in the Sprout Lands pack, there's these tile sets. Those are what we'll use in order to create our tile map.
I'm just gonna import everything from that pack. So this is missing from the characters folder. Right, and then let's add objects and tile sets. Okay.
So with tile map open, down here at the bottom, we have tile map. And then in the top right, inspector tile set. So we want to create a tile set. So I'm going to click new tile set. When you do that, there's a new tab called tile set down here at the bottom. And to create a tile set, we need to add an image in here that we will use for our tiles. So let's start with the grass image. I'll just drag this over here. It'll say Atlas texture was modified. Do you want to automatically create tiles? Let's do yes for some.
Okay, so I have tile set. He's using 16 by 16. Yes. Yeah, this looks correct.
Simplicity. And you'll see in Godot 4 that it will automatically slice up the image into the individual tiles that we can use for drawing on our tile map. So now if we click on tile map, you can see our tile set over here is available, and we can left click on a tile and then left click on our screen to start drawing that tile. So you can select any grass tile you want to be the base ground and just add some variant tiles for some options.
Mm-hmm. Okay. Interesting.
You can also select a whole bunch of tiles and then use this random tool. So if I select all of these and then I start drawing around,
Oh, wow.
then you can see it's actually going to randomly select between the tiles that I have selected. So usually though, when you are drawing your tiles, you don't want to have too many of the fancy tiles that have these extra information. You just want to use those sparingly. So if I hold shift and I left click on this one down here, then I can have all of them selected, including the normal grass tile. But even if we can have that normal grass tile, it doesn't appear enough. So what you could do is turn off the randomness. And now let's take the rectangular box tool with the center grass tile, just the normal one. And I'm going to drag a huge box around our scene that can be our base ground. I'll actually make that even bigger. So now to make these randomly appear when we draw, but not on every tile, in order the random selection, and let's take the scattering and make that something like 20. So now if I use the pencil tool and I draw, it'll appear, but not on every tile we hover over. So if I hit Control Z and I select all 10 now, I can draw with the pencil tool and kind of go around, and it will sort of randomly distribute the tiles that I want to randomly select from. So we get a interesting variation of the tiles added onto our grid automatically. We can also Control Z that and then use the fill bucket and just select this whole thing at once, left click, and there you have it filled in, all of the original grass tile with randomly selected tiles. So if I hit Control Z now, I can increase the scattering further to make it less likely. So I'll do 50. Now let's left click here. And I think it appears less. So I'm actually not totally sure if this is a percent chance out of 100. So the higher you set your scattering value, then the less likely it's going to appear when you fill in. So if I left click here with the scattering of 50, you can see that some of them are filled in, but most of them remain the original. But if you have a scattering of 0, then left click, every single tile gets filled. So just play around with your scattering settings, and that can be an easy way to kind of get a randomly generated map here.
This is cool. This is really cool. Can I... So, we have these things, and the center, wait, and the center one. Wait, what? What's going on? Ah, okay. But it's not selecting what I asked it to. That's some spaces. Okay. What the hell? Do I need to... No, this is weird. Ah, okay, I understand. So first, we need to paint everything without scattering. There we go. And then we can select whatever random stuff that we want, and we can just do that. Aha, I see. Okay, this is cool. Okay.
Can use as your base. And then for anything else like paths, you can draw that on top when you need something that isn't just a random detail. So I'll go ahead and turn off scattering. For these other tiles that actually have some transparency in them, what you'd want to do with them is put them on a second tile map layer. So if you look in the inspector for the tile map layers down here, we can name the first layer base ground. And then I'm going to add an element. We'll call this top ground, I guess. Hit enter. And now, when we're selecting these tiles, we change base ground to top ground. So we're showing where we're going to be drawing them on. You click the tile you want, and then you can add it to the level here. So if I click off something else, you can see these tiles actually rest on top of the back tiles instead of being their own thing. So if you don't have layers, then it would look something more like this, where you just have these transparent areas, and that's kind of weird. So sometimes with tiles and objects, you have to layer what you're trying to create. So let's go ahead and create some more tile sets. I'm going to click on tile set. I'll just drag hills in here. Hit yes to auto create them. Tile dirt. Add it in. Auto create. Water. Auto create. Why not just keep going? Wooden house. Auto create. And fences. Auto create. So definitely this aspect of Godot 4 is a lot simpler than it used to be, for sure. Okay, so now with these cliff tiles, we might want to have another layer. So make sure the second one is top ground, but then I'll add a element and I'll call this high ground walls and hit enter. Okay, so now when we add stuff like the hills walls, we probably want to make these tiles so that they can't be walked into. So let's work on collisions. I'm just going to add some hills over here, and I'll add the extra stuff over here as well. Then you'll see I'll be able to walk right into it. Oh, well, we can't even see the player actually. So let's go ahead and fix that actually.
Yeah. Guess we I just want to try and guess what we need to do, because I saw that in order, I guess, either Z index or wire mask or visibility layer. Probably that's what we need.
So for the tile map, I'm just going to make it so that the ground always displays under the player by changing the Z index in the layers. So base ground, I will make -5, hit enter. Top ground, -5, hit enter. So the player will always render on top of those objects now because the Z index of the player is 0. So it ranks higher. So let's hit play now. And then we can move our character around. But you can see I can just walk right onto the cliffside, which is not what we're looking for. Also, I'll try to add in some extra grass. So let's click on tile map. So we want base ground and rectangle select. I'll just add in a whole bunch more stuff so that we don't see the edge of the map, at least for right now. But for these hill tiles, we need to make it so that they have collisions. So how do we do that exactly? And I'll show top ground so that we...
But wait, not sure if this is exactly what I want. To define, like, wait, where did he set the Z index? Layers, on tile map layers. Ah, there they are. Z index. What are these visibility layers? The rendering layer is which hits canvas item is rendered by viewport nodes. Interesting. So in theory, we have a ground, we have walls, I guess. We theoretically could have some kind of roof or something that goes above the player, or some decorations, right? Wait, how do I add more tile sets? Oh wait, I'm in the wrong view. I'm in tile map. I need to be in tile set. Okay. Grass hills. What's the difference between these ones? One sec. Let me take a look. Okay, we have grass, we have hills. Can I ignore the dirt for now? Water. Water, I guess, needs to be on its own level, because otherwise I'm not going to be able to paint it properly. Because we don't have like transitions from grass to water. Then the water has to be in its own layer. And it has to be below ground. So let's see if that works. So if I draw some water here, right, that's ground water, right? That's actually animated. Oof. Okay, for now, let's make it static. But yeah, it's animated, I guess. Terrains. And now here I can paint something like, I don't know. Oops. All right, we have the boundary. this one, right? Yes. Ah, right. We don't have the controls to actually move around properly. But that's okay. This is not okay. I forget to save, I think. Navigation. Okay, so we have the water here. I think I need to change this script and remove the gravity, and we don't need to jump, I guess, for now at least, and just need to move around in 4 directions. He's on floor. Okay, let's see.
More tile sets. I'm going to click on tile set. I'll just drag hills in here. Okay, so now with these cliff tiles, we might want to have another layer. So make sure the second one is top ground, but then I'll add a element and I'll call this high ground walls and hit enter. Okay, so now when we add stuff like the hills walls, we probably want to make these tiles so that they can't be walked into. So let's work on collisions. I'm just going to add some hills over here, and I'll add the extra stuff over here as well. Then you'll see I'll be able to walk right into it. Oh, well, we can't even see the player actually. So let's go ahead and fix that actually. So for the tile map, I'm just going to make it so that the ground always displays under the player by changing the Z index in the layers. So base ground, I will make -5, hit enter. Top ground, -5, hit enter. So the player will always render on top of those objects now because the Z index of the player is 0. So it ranks higher. So let's hit play now. And then we can move our character around. But you can see I can just walk right onto the cliffside, which is not what we're looking for. Also, I'll try to add in some extra grass. So let's click on tile map. So we want base ground and rectangle select. I'll just add in a whole bunch more stuff so that we don't see the edge of the map, at least for right now. But for these hill tiles, we need to make it so that they have collisions. So how do we do that exactly? And I'll show top ground so that we can see the hill. So if you click on tile set, then we want to add some extra properties to these tiles so that there's an actual collision. So there's this paint properties button. If we do select properties and then we choose physics, well, we can't choose physics yet because we haven't actually created a physics layer. So let's do that. In the inspector for the tile set, expand physics layers, add an element, and you'll see collision layer and collision mask are both set to 1 here. So that's the default collision layer. So the player is already looking for collisions by checking if anything exists on collision layer 1. So if we paint properties down here and add these tiles to collision layer 1 by referencing this physics layer, then they should collide with the player, or rather the player should collide with them. So select a property, physics layer 0. That's the first item in this list here. And you can left click on a tile and that will automatically create a box shape around the edges for a collision. So if you just want it to block out the whole tile, just left click, and let's go ahead and hit play and test that collision. So we try to go here and our character actually can't walk through the wall, but it can still do the other areas, of course. And we don't want to make it so that this area can be completely unwalkable, because the only area that should be blocked is probably this edge here.
Okay, let's revert back because I need to do player movement for this style of game.
And when we hit play the project, it's going to say that there's no main scene. Click left, right, script up button in the top right. Okay, so now to add a script to the player cat, let's click on the root node here, go over to the inspector, and down at the bottom, there's this area here. Script can do everything that the character body under it can do already. So it's building on top of what already exists. And we're not going to use the template for character body 2D basic movement. This adds extra stuff like jumping, which right now don't actually make sense for the character. So we'll just write a couple lines from scratch. And for the path, you can see that it defaults by storing the Godot script into the same folder where our player cat scene is. So I'm just going to stick to that convention and hit create. So now we have the player cat Godot script inside of the folder. You can also see this icon next to player cat showing that a custom script has been attached to this node, which gives it the extra functionality. So anytime you want to edit the script, you could just click here. You don't necessarily have to find it in the file system. So in order to move our character around, we're going to put the code that causes that to happen inside of the physics process function. So physics process will run a certain number of times per second, along with every other object that has a physics process function. Everything on your screen is going to get calculated and moved at roughly the same time with physics process. So anything that's going to be moving and colliding.
So for our case, we don't need to check if we're on the floor. It's irrelevant for us, and gravity is irrelevant. Right? Or no? Still trying to figure out what kind of game I want to make. For now, I think I'm interested in top-down. And yeah, that means that we don't need gravity. And jumping, at least not for now. So this is not needed. This is horizontal direction. What if I just copy that for the vertical direction? I want to see if
generally want that
how
code
this guy
to be
does this.
score because it knows not the keys directly. So to do that, you can type input.get action strength. So in terms of a key press, this is whether it's pressed down or it's not pressed down. And you can see that the action is a string name. So I am going to put right.
And for controllers, does it recognize the strength? What's going on? Why are we dancing? Oh, did I miss a follow? Edit. Why didn't I see that in chat? I'm sorry, my alerts are broken. I think Stream Elements is acting up. Probably. But yeah, thank you for the follow. Probably that's why we are dancing. Thank you. So, instead of that, move and slide.
Here for the first action, and we're actually going to subtract input.get action strength left here. The reason for that is that our right arrow or
I like this because looks like we're gonna do both left, right, and up and down, which is good. And hopefully this input strength works nicely with the controllers. So the more you deflect the stick, the higher the strength would be. That would be awesome. So this is input, get action strength. Right. UI right? Huh. Maybe that was for an older version of Godot. And this is down minus up,
E
I guess.
on the keyboard is going to cancel out keyboard. So if our and for
Yeah, down minus up
names
because we
that-
have an inverted y-axis.
match these in the import.get action strength. So I'm going to type in right and hit enter, left, enter, down, enter, and up, enter. So that creates our 4 actions. And now these actions can have multiple types of import attached to them. So you might have a keyboard import for the action, and you might also have a controller import. So that's why you get the action and not the direct key press directly, so that you can account for other import types.
And then we can do velocity, not x, but velocity, plus equals, I guess, input directions times speed. I'm just curious what's gonna happen. Probably need to normalize the vector or something.
Today we're just going to be using the keyboard. So I'm going to hit plus over here to add an event. And that event is a key press. Even add OK. You can see that gets added to the list. Working. I'm going to add another line of code, which is going to be print now, and especially one that can be customized in the inspector.
Where does it print? In the console? Yeah. And right now it only works with the buttons. +1, -1. But it doesn't work with the controller. Why? It was working with the controller. Input map. UI left. Yeah. And JPEG access. Ah! Okay. My controller went to sleep. There we go. Yeah, and it does work nicely here. But the dead zone is really high. Okay. And it's already normalized, so it's 1. Now, why doesn't this work? Oh, that's velocity. We just set the velocity and we should be good. This is weird. Like, it's perfect for the keyboard, but for the stick? super high dead zone. So I guess we can just... Oh no. Oh no. Not the FBI. Hello, Plane Shift. How are you doing? Thank you for the raid. Thank you, thank you. Let me shout you out. Thank you, thank you.
Freaking
How are you doing? What were you doing on stream?
long leggish. What the hell is going on in this life? What the fuck? Huh? What is that? Oh my god, this game is all fucked up. This game is completely fucked up.
But yeah, welcome everybody. I'm just trying to learn Godot and see what it's capable of and figure out like how to build a very small project on it. So far, I think it's gonna be like a top-down game, but we'll see. Instead of action strand, you could also use input get vector, and you can set the dead zone. Get vector right away? Wait, what? Aha. Negative, positive. Aha. And the dead zone. Uh-huh. I see. I'm gonna do that in a moment. Did I miss anything else in chat? That looks like a funny one. The funny clip. Yeah, I liked it. Scared. Get to another room and some guys scream. Okay. Sorry about that. But yeah, we had a raid. Let me duplicate this. What Control D does? I'm used to it being a duplicate. So this is gonna be input. Get vector. And now we define the names of the input. Right. So negative x, that's left. Also probably I should create left, right, up, down separate to the UI. So negative x, that's left. Positive x, that's right. Negative y, that's up, right? And the dead zone minus 1.0 by default. By default, the dead zone is automatically calculated from the average of the action dead zones. However, you can override the dead zone to be whatever you want on the range of 0 to 1. So if I don't want to change the dead zones in the mappings, in the input map, I can just specify whatever I want directly in the script. Not sure what would be the best, but let's do something like that for now. There we go. Now this is smooth. And we can move slowly, we can move faster. And the keyboard also works perfectly fine. And the D-pad works perfectly fine. Okay. But yeah, thank you, Jekyll Gamer, for the suggestion. This looks nice. But okay, now we can move, but our camera doesn't move. So I guess we continue following this tutorial
Without
for the
having to
camera.
go into the script.
Sometimes the vector version can choose a biased direction with gamepad input. What do you mean? Sometimes the vector version can choose a biased direction with gamepad input. Press left and it kind of moves up to, I guess that's dead zone. Like it's like an analog stick, it's impossible to set it straight left. So this is why I set the dead zone to 0.1. Even with that, it's hard. No, it actually does. Wait. Oh, yeah. The dead zone doesn't work as I expect it to work. Actually, no, it's actually fine. So, let me write it down. Not write it down, but draw it. I need to visualize that a little bit. So we have where is the thickness? So let's say we have, maybe I can just draw a circle. So we have our analog stick, right? And right now, let's say we're in that center. We have a dead zone. Like let's say something like, oh my god. Something like that. So if we move that stick within this dead zone, nothing happens. No input will be detected. So right now well, 0.1 is probably a bit too much. But yeah, I can slightly deflect the stick and it doesn't register. But let's say I move it. Let me actually try and set a higher dead zone, like 0.5 for now. Yeah, like as soon as I deflect the stick, let's say to the right completely here, it starts registering whatever information it supplies. So if it's slightly down, it's gonna be slightly down. And I think that's correct. I think that's good. Is that what you meant? You could also get input vector round and it will respect it. No, I need... Yeah, I want to have variable speed. I want to be able to move slower if I deflect the stick only slightly. Like, I don't know how to say that. But you use variable speeds with analog. With analog, yeah. But no, I think that's fine. I don't think I need like more linear movements. For now, I want to have like complete freedom. And later we will see, maybe we will limit that a little bit. And I think with this, dead zone, no, wait. Yeah. So if I set this dead zone to -1 by default, this behaves somewhat like the keyboard and mouse. No, it doesn't. But okay, I know what you mean. Those are like two different styles of controls. Why we either allow like fixed movement, let's say a movement fixed to axis plus diagonal movement, or that would be like on the keyboard, or we give complete freedom with analog sticks. So I understand what you mean, how to implement that, but I'm not sure if I need that right now. Probably not. Right now I have like a complete freedom. I can like pixel perfect place my character where I want it to. Okay. The input get access will allow you to separate the X and Y values. We all need to do over direction. Yeah. Yeah, like this completely separates the axis, and this one is more like uniform movement. Also, another decision to make is subpixel movements. Because technically our screen renders 1 pixel as 4 pixels, just in the camera settings, like 4 times zoom, but I can place my character in subpixel coordinates. But again, that's more like gameplay or even style decision. I'm not sure what would be the best for me right now. For now, we're gonna go with this. Okay, camera. Do we have camera in this
Every
tutorial?
time we want to change it. So I'm going to add above all.
Because I have an idea how to implement that. Also, I didn't need the direction. Well, we can just comment it out for now. For camera, I think we need some kind of bounding box around the camera coordinates or something. And if the character moves out of that bounding box, we move the camera but do it smoothly. Like I have an idea how to do that. Position shaped. We'll fix the snapped, sorry. Cannot read. Position snapped, yeah. So it snaps to one unit. I guess I need to do that after move and slide. Move and slide, I guess it applies the velocity, right? Can I inspect it or something? Moves on the body based on velocity, yeah. If the body collides with another, it will slide along the other body. We don't have collisions yet in the world. But yeah, I guess after this method, how do I go back? Let me try that. I want to see how that looks like. Just position equals position snapped. Wait, what's going on? Is it? I think it's too fast. Yeah, now no, that's weird. Snap to the nearest multiple. It makes sense. It works, but it feels weird. Like it's too fast a little bit, or I think I understand. Like now our speed, our minimal speed is 4 pixels, or one like graphical pixel or pixel of graphic per frame. Can I get rid of normalization? I'm trying to figure out if I can place it as a subpixel. I don't think I can. So that solves that problem, but yeah, the movement is now... It feels like almost I lost the variable velocity or variable speed completely. No. Still there. Let's see. Oops. 1, 2, 3, 2. Yeah, we still have a variable speed, but it's very subtle. Trying to figure out why it's happening logically. Yeah, I'm just gonna remove it because I'm still not sure what would be the style of movement. Like, do I even need this? Because probably I don't need this at all, and I can just freely move around. So yeah, basically to move slowly, I need to move with subpixels, but probably to implement it as I want it to behave, that would be like 2 separate objects. One would be the object that we move with the input, and the other one would be the object that we render. So those calculate differently. Or maybe not object, maybe just some virtual position and then snapped position. Before moving slide. Don't think that would matter. No, I don't. Well, actually, it does change something. I'm just not sure what. It snaps back. But yeah, I think to make it work, like it can move very slowly but snap to the pixels, then I would have to implement something like virtual position or input position, which would be calculated by the velocity, and then update the position afterwards by having that virtual position snap to that. But then during the velocity like movement calculation, we will have that old virtual position as the base position. I don't know. I don't need that right now. It's just an interesting problem to solve. For now, I really like this. Okay, so
functions on line 3 right here. And this is going to be different than Godot 3. They changed the syntax a bit. So at export makes it visible in the inspector, and then var move underscore speed. We can put a colon and define what type it should be. So I want it to be a float, which is a number that can have an optional floating decimal point, and then equal to, let's say, 100. Okay, so now if we click on player cat in the scene hierarchy, then you'll see this move speed variable shows up here. So anytime we want to change the move speed, we can just click here and type in whatever number we want for test.
nice. What's the syntax?
Point, and then equal to lucky, then 100. Okay, so now if we click on player cat,
Nice. And then how
so
do we
now
use it?
it actually already knows line because we've already made sure.
Just move speed. Okay. Okay.
But move and slide, basically, if you come against a wall, but the character can still kind of move, then it will slide along that wall rather than just being stopped altogether with a full-on collision. So let's get rid of the move and collide. Move and slide is going to make more sense for this character, at least for now. So let's click on game level. I'm going to hit F1 on the keyboard to switch to 2D view. And let's go ahead and hit play and test how our character can move around the screen. W for up, A for left, S for down, D for right, and it's all working. We can also press multiple keys at once. I'll try A and D at the same time, and you can see that actually stops the character altogether. And same for W and S. That things actually appear much more zoomed in by 1008, and make it so that things actually appear much more zoomed in, so we can actually see our pixel characters. Let's go up to project settings, general, and then we want to find window here, display window. So let's set a custom viewport size. I'm going to do, let's say 1920 by 1080. So this is going to be how much space on the screen you want the window of the game to take up when you hit play. I'm on a bigger monitor right now, so this is still going to be only like half of the monitor. And we also want to stretch the game and make it so that it appears bigger than it actually is. So I'm going to do stretch mode, canvas items, and I'm going to do scale. Let's set it to 4 for right now. Okay, let's go ahead and hit close. I'll hit play. And as you can see, everything is much, much bigger than it was before, which actually allows us to see the character, and when we get around to it, tile map, objects, stuff like that. Okay, so now that we can visibly see our character, let's actually add some animations to it so it's a little bit more interesting. So I'm going to close out of game view, and on the player cat scene, I'm going to right click on the base character body and add a
follow camera. This is what
another thing we might want is a follow camera that will actually follow our player around, because right now the player could easily run off the map like this and it can come back. Some games would actually just have the camera be static and then change when the character switches to another level, like your Zelda games. But if you want a follow cam, which is totally legitimate, we can add one to the game level really quick. So I'm going to right click on game level, add child node, and this is just the root 2D node, by the way. So camera 2D, and then we need to point the camera 2D at something. So first I'm going to set it to current, so this is the active camera. Then I'm going to right click on the player cat in the scene, add child node, and then look for transform, which is going to give us remote transform 2D. So this gives us a location that we can assign to another node like the camera for it to look at. So create, and then where remote path is, hit assign, and then choose the camera in our scene. Now if we hit play, the camera is going to follow our character around. So as it is right now, it's just perfectly staying on top of it with no smoothing or anything. If you
This is amazing. Okay, so we add remote transform 2D to the player. We assign the camera that we have. Okay, but yeah, now I want it to be like in a bounding box.
close, you can go to camera, and there are settings you can change for that, like smoothing enabled.
In the camera. What the hell? It looks super janky. Okay, let's see what's going on. The ground is actually pretty smooth. The problem is the character is not smooth at all. Smooth and bad with low res. Why though? Like the ground is pretty smooth, but the character is weird.
If we hit play now, you'll see that this is a little bit different, but you can also see it's kind of glitchy when it comes to pixel art. So the easiest way is just to have that off. So to go ahead and speed up setting up these cows a little bit, I went ahead and wrote part of the script, and
Using canvas mode or viewport mode and stretch modes. I have no idea. I think viewport. I don't see any difference. Why is the character glitchy? Like we still have the subpixel movement. Oh. Viewport is pixel perfect, so it will not allow subpixel. No, it's fractional. Viewport is pixel perfect, so it will not allow subpixel. Hence the jitter canvas allows subpixel. That's scale mode. Still, I don't see any difference whatsoever. It's still super glitchy. Can I easily disable a node? Like completely remove it from the logic, but leave it there temporarily. Disable. No. Stretch mode further down. Isn't camera directly to the player? That's the thing. I don't want it to be like locked onto the player. Or do you mean just place the camera into the player? No, doesn't matter. It's just, I don't understand why this happens, because the ground is smooth. I don't see any, no, it is jittering a little bit still. You can see that. Weird. Also, the logic that I want to implement is slightly different, at least something that I'm imagining right now, is the character can move freely like in the center of the screen. Camera stays the same, but when we move closer to the edge, then we start moving the camera. But again, with some smoothing, I guess. Camera is channeled without the transform. Then we... Oh. It's the same. And again, the ground is smooth, more or less. Now I can still see some kind of jittering, maybe. But the character is all over the place. Really weird. I just don't understand why that happens. Pixels per second. Like, what the hell is going on here? No, the ground is also jittering a little bit. So I guess smoothing is not an option for me. I still snap in the player's position. No, I'm not. What's going on here? I guess I didn't save. No, I'm not. And suddenly with the smoothing, right now it's completely locked in place. But I want it like on a stretched string or something like that. I don't know how to describe. But yeah, I guess that would be pretty complex logic, and I don't see anything. Wait, what is that? Drag. Camera only moves when... Oh. Oh. This is what I need. If true, the camera only moves when reaching the horizontal left and right drag margins. If false, the camera moves horizontally regardless of the margin. Yes, this is exactly what I need. Okay, so it's built in. No logic needed. So margins, I guess something around 0.8. Yeah, the top margin is weird. Oh, wait. Did they? Oh, I didn't save. Okay. The top margin is still weird. But left and right is exactly what I wanted. Track helps the jitter a lot because it doesn't do both directions together. The top margin is weird though. Does it work? Yeah. It's just weird. Or is it that's probably the collision of the player. So maybe not 0.8, maybe something like 0.7 for everything. Or just yeah, 0.6 for the top one. Just because we have additional height to the character. But yeah, this is what I wanted to have. Probably smaller margins. Maybe 0.6 on every axis. In every direction. Did it save? No, I guess the top one is weird. Top one needs to be lower, 0.4 maybe. Wait, that's left. No, that's too much. 0.5. Yes. Okay. I like this. Nice. Okay, perfect. So everything that I needed was built in. I'm just curious. I'm gonna turn on the smoothing again. See how that behaves. Yeah, I don't want to use that. Just the drag. But also, right now, we tied our camera directly to the player. I still want to have it separate. But then, what was the node? Remote transform 2D. We select the camera. Yeah. Okay, good. Also, the limits will log the camera to boundary. What do you mean? Limits? You mean like collision and stuff? Like world boundary. Let's test that, by the way. Camera limits tab inspect. Limit. I see. Okay. Thank you.
Advanced. states. So let's talk about it.
Keep clicking on
First
this
off,
tab.
one way of setting up states is to use an enum variable. So this can basically tell you what a
So wait, what do we need? What's next? What's the next step? I don't know what's the next step. We have our very, very base logic. We can move around. We have some ground. Somewhere there at the bottom, we have water. Yeah. We don't have any collisions. So this is probably something I need to play with next. Hello, YouTube?
you can see the hill. So if you click on tile set, then we want to add some extra properties to these tiles so that there's an actual collision. So there's this paint properties button.
Let me paint some cliffs. Or not cliffs, hills. So what do I want? Let's build a small platform like this one. Oops. Wait, are we running the game? Why is debugger? Delta is never used in... Okay, whatever. We will use it eventually. So what do they want? Tile map. Tile set. No, tile map. All right. By the way, can I... Oh, yes, I can. Select it like this, but I need to... Health. What am I doing? How do I do this? I guess I need another layer for the hills, but I wanted to make the top of the hill walkable. I guess we just paint the hill walls, right? So we need another layer. Let's set this to -10, this to -20, water to -20, hills to -5. And let's try to paint a small hill. Whoops. Hills. Can I just do it like this? Yes, I can. Nice. So we have a hill like this, just a test one. Then let's do one more, but I want to be able to walk. Oh, I guess it needs to be wider. Okay. Now, how would it look like if I want to walk from the side? Oops. Is this what I need? Not sure. Let's look at the asset page. Not sure if they even have something like that. They have one that is walkable from the bottom to the center. How is it supposed to look like when I want to walk on it from the sides? I'm pretty sure it's possible, it's hard for me to imagine with this tile set. What are these tiles for? Okay, so this is for like, I don't know how to describe, but I think I understand. And yeah, that's not what they need. Okay, I guess that's it. Let's try at least these ones. So now tile set. Let me try to remember where was the collision physics layers. Where was it? Here, I guess. I need to look at the video again.
If we do select properties and then we choose physics, well, we can't choose physics yet because we haven't actually created a physics. We do that exactly. And I'll show top ground so that we can see the hill. So if you click on tile set, then we want to add some extra properties to these tiles so that there's an actual collision. So there's this paint properties button.
Can I select multiple points? Actually, I don't want multiple points. I need it to be like that. Oops. Okay, for all these three, even for these ones, two, and these ones, and these ones, and this one, and these ones. We're just gonna do like almost half of that space as a collision. Right? Why is it not applying to everything? Perfect. Now we can tweak this around a little bit. Actually, that's pretty good. Now the sides. How do I... Wait. What? I don't understand. Okay. So this one. What the hell? There we go. I don't understand how it selects everything. I just need to... This is a weird UI. It's broken. Okay, so now I want to select a single cell. Make it like this. Right? How do I apply it? Like it doesn't show up here. Which one was I editing? This one. Now I want to select a different one, but I want to edit the existing pattern. This is weird. I don't understand how this works. Like, how do I revert to default or to the current one? Or do I just do it here in the select interface? I guess so. Aha, control click. Aha, okay. Now for this one, we need to be like this. These ones will be different, but okay. Let's say that these ones are, wait. These ones are completely different actually. You don't even need to have the center walkable, I think. Those are just, oops. How do I? Wait, no. How do I do this again? How do I? Ah. This tool is frustrating. I don't understand how to deal with it. Aha. This is the reset. So now we just adjust this thing. Which maybe something like that. It's gonna be weird, but okay. What? Okay. Okay. These ones are still something that we need to do, but this is already good. Okay. So far, so good. So, where are we? Tile map, tile set. The top ones. Like that, I guess. Now I cannot get in here. That's good. Oh, but this corner now is bad. So I guess we need to do the very edge. Do we actually? Maybe not. Maybe we can leave it like that. And yeah, I guess with this style of game, we need a different collider. We need the legs to be the collision. Yeah. Where was it? Player, right? Collision shape. Can I rotate this capsule? I want it to be horizontal, not vertical. There we go. There we go. Now it looks good. It gets stuck on something here. But, okay, proof of concept is here. But I want to be able to jump. Just maybe visually. What was the jump here? And this on floor. Yeah, this is gonna be different, so maybe it's gonna be just visual, so we just adjust the sprite position, but not the actual player position. I don't know. For now, I'm not gonna bother with that. Yeah, now I need to also adjust the grass layers. But okay, that's another thing. So far we have the actual movement working. Okay, what's next?
If we do select properties and then we choose physics, well, we can't choose physics yet because we haven't actually created a physics layer. So let's, and our character actually can't walk through the wall. You just paint properties down here and add these tiles to collision layer 1 by referencing this physics layer, then they should collide with the player, or rather the player should collide with them. So select a property, physics layer 0. That's the first item in this list here. And you can left click on a tile, and that will automatically create a box shape around the edges for a collision. So if you just want it to block out the whole tile, just left click, and let's go ahead and hit play and test that collision. So we try to go here, and our character actually can't walk through the wall, but it can still do the other areas, of course. And we don't want to make it so that this area can be completely unwalkable, because the only area that should be blocked is probably this edge here. So hit stop and go back to the tile set. Let's add in a more detailed shape for these edge areas. So I'm going to left click on this tile, but then in this editor, I'm going to drag the corners over to the left so that it's actually only blocking on the far left area of the tile. So if I left click our next one, I guess that actually automatically created that there. So if I left click here, it's going to do the same thing. Let's use the move tool and drag this over. So click on the tile you want to copy that to. And there's also this edit points tool. So I'm going to click on this tile, which this should be over here. And I'm going to drag these points to the right, kind of like so. You can also add more points. So if I do click, 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 and then over here as well, and back to the first one, then we kind of have two collision shapes inside of one. Actually, we could probably just make this whole thing one shape. It doesn't have to.
We did all of that already. That's good.
Okay. And I'll copy over to here one more time. You can stock up here and then rotate it. So rotate to the right, click, and okay, there we go. So now we have.
Wait, how do we rotate?
Okay, that looks good. And now let's click here and then rotate it. So rotate to the right, click,
okay.
And okay, there we go. So now we have the collisions for this entire cliff done. And if we hit play, we should not be able to enter from any side, which is great. So that did take a little bit more work, but by properly setting up the tile set collisions, I can click on player cat and just drag him into here, hit play, and I should be able to walk around up there, as you can see here, but I can't walk off the cliff. So now I have the illusion of having high ground and low ground, and I would need something else, kind of like the staircase tiles, in order to get up here to use this high ground. So a quick thing I want to point out is that if you have the move tool, you can actually accidentally move the tile map quite easily. So I'm going to Control Z that. And what you might want to do is lock the tile map in place at the transform 0, so that you don't move the entire map. So if you just click on tile map and lock it.
Oh, I need that. Wait, where is it? Okay.
And now if you try to move it, you can't, but you can still paint on it. So if we go back to selection mode, click down here for the pencil tool, select what you want to paint, and then click over here, you can still do that. So I'm going to draw more top cliff areas. Let's just replace the tiles there. So as you can see, it is a little bit glitchy still for the alpha version of Godot 4. But let's go ahead and just kind of get this made. So that, and we'll need those. But for this corner, I think you need this tile. So let's just add that in there and that can work. So everything else can just be the tiles we already set up, I think. Eraser tool for this one down here. And let's add in the staircase tiles. So let's paint that in. And so now if we hit play, our character should be able to walk out of here, but not onto here for any spot, which is really cool because now we have the illusion of having 2 levels on our game. You just need to control the collisions and make sure that you use something like a staircase when you're going up the ground. Of course, right here, this tile, we may need to add a collision into that if we want. But aside from that, that is working pretty well. So I am going to remove that one tile there real quick. Let's go ahead and save the map. So another thing we might want is a follow camera that will actually follow our play.
Okay, one very important thing that I skipped is I need the player sprites to adjust to the movement direction.
Player bound, because right now because we're dealing with Pixar and we have the wrong rendering settings, and you can see default. Okay, so second problem. We see the entire sprite sheet at once, but what we actually
Oh my god, I'm so confused in the windows.
want a bunch of animation H frames and 4 for V frames because this is a 4x4 grid. So 4 and then 4. And now it's only going to be showing the first frame in that set because our frame coords 0, 0 means we're at the top left of that sprite sheet. So now before saving this character scene, I'm going to let's add it to the game level scene. So click on game level. You could right click.
Well, I'm using animated sprite 2D. I guess he's animating that manually.
And jump nodes. Add a shape node and adjust it. These out. This one in the top right hand corner. Select and we will find character with script can do everything that the character box and the folder.
Okay, so you
can also see this icon next to player cat showing that a custom script has been attached. And a Y value, our input direction not pressed for that is that out.
Okay, so we saw that.
Import for the action, and you might also have a controller import. So that's why you get the action to move. It's going to be the direction times the speed we want to move. So how do we know what speed?
Animated
so I'm going to close out of game view. And on the player cat scene, I'm going to right click on the base character body and add a child node. Search for animation. And then there's going to be 2 nodes we're going to need for the scene. One is animation player and one is the animation tree. So let's just add both of those in real quick. Now to create the actual animations, you do that on the animation player. So if you click on animation player, you should see this new window animation down at the bottom. So we want to jump into that and then click on this animation button and choose new animation. Give it a name. So I will start with walk right and then hit enter. So how animation works in Godot is through keyframes. So almost any property in Godot, you can actually attach a keyframe to. So you might notice when
that's definitely not the way we need to go. I think we need to go back to the first tutorial.
Now at the bottom here, you can see that we have 2 tabs. We have the tile set and tile map.
Yeah,
so before
let's watch this tutorial through the world building section. Maybe we get some more
painting
tips.
With our tile map, let's go into our tile set and configure this property. The main thing we want to do is drag in our tile set asset. So let's go into our assets folder under sprites and drag in the world tileset.png. It's going to ask us if we would like to automatically create tiles in the atlas. We do, so let's press yes. And now let's make some more room here, and we can zoom in to view it. And as you can see, it's actually gone ahead and automatically detected the grid cells that have tiles. If for some reason it's made an error, we can always use our eraser here to remove tiles. In this case here, it thinks that the top of the palm tree is a bunch of different tiles. I'm going to use the eraser to get rid of these, and instead go out of the erase mode, and then hold down Shift while clicking and dragging to turn this into one big tile. It's also split up the trees into 3 different tiles, but in this case, it's actually something that we want, because it allows us to create trees of varying heights. I'll show you this once we start painting. Other than that, I think it looks good. So with this tile set up, we can now go to our tile map and start painting. Make sure that the scene has the select tool and that the tile map has the paint tool enabled. And now let's simply select a tile and start painting it in. If you make a mistake, you can always right-click to remove. So I'm just going to fast forward through me drawing out the level here. As you can see, I begin by blocking out the most essential game parts, leaving in room for gameplay objects like moving platforms and enemies. And then only once I'm finished with that, I start decorating. And if the trick here is that you can select multiple tiles at once to paint in more than one, and you can always go into select mode in order to select large chunks and move them. The bottom, then choose how right off. That's because we need to add a physics layer to our tiles. To do this, we go to our tile map, go under our tile set, physics layers, and add a new layer. Then with this layer, we can go under our tile set, and here we need to choose what tiles belong to the physics layer, because we don't want to collide with everything in our tile map. The trees and bushes, we just want to pass right through. So let's go to paint here, and the property that we want to paint is the physics layer 0 we just created. And now we can actually go ahead and paint onto our tiles these physics settings. So I'm simply going to paint this onto all the different solid tiles. And if you make
I understand now. Like, I needed to watch this 3 times, I guess, and test it by myself. So the paint tool allows you to like select your brush basically shape or configure the brush shape. And then when you click on a tile, it applies that shape to that specific tile. I was trying to work with this from like a different perspective, that I, for example, select a tile and then I edit it. This is not the edit tool, this is the brush tool basically.
a mistake, and once we remove a tile, we go here, select clear, and now we can paint with no physics, or we can go back to the default tile shape, which is the entire tile, and paint with that, or simply hit F to do that. So C and F are the shortcuts here. Now, there are also some tiles that we do want physics on, but where we need the collider to only be on part of the tile, such as our bridge here. So if I zoom in on our bridge, we can see that if I just paint physics onto these, it doesn't look right. Instead, we need to go in and only paint a partial collider. So over here on the left, we can actually modify these colliders to exactly suit our needs. We can even add and remove points by clicking and right-clicking. But in this case, 4 points will do just fine, and that's a good shape for our collider. Then we can paint these onto the 3 different tiles. And then for the next one here, we can configure it. This slants up a bit. I'm going to paint that on as well. And then for the final one here, let's go ahead and make that go in the opposite direction. And here you actually want to be pretty precise whenever you have an overlap of the colliders here. I think that looks pretty good. This helps avoid that our character gets stuck. I'm also going to take the tile map and drag it to the very top so that we can always find it. And now when we play, we are indeed colliding with our environment. Awesome. Now we probably want our camera to follow the player because he's currently just running off the screen. So I'm going to make some room here. I'm going to take the camera 2D and simply drag it under the player. Making it a child of the player means that it will just automatically follow the player node. I'm also going to make sure that the camera is still positioned right on top of the player. And we can even turn on position smoothing to really smooth out our camera follow. So
another thing that I'm struggling to comprehend in Godot is here, for example, we have the player scene that has two child nodes. But in the game, we also have this player scene as a node, and we added another child to it. How the hell all of this works? I don't know. Oops.
I'm going to enable position smoothing on the camera with a default speed of 5 pixels. And now when we play, as you can see, our camera smoothly follows our player. Awesome. So now we have a first draft of our game world, but so far everything is stuck to the grid. Let's start adding some dynamic and moving elements, such as platforms. Platforms, some that move and some that don't. So whenever we are creating a new element of our game, we begin by making a new scene. And for the root node here, I'm going to hit add and search for the animatable body 2D. This is a physics body that we use whenever we want to animate a node and still have it collide properly with other nodes in its path, which is perfect for moving platforms that should still collide properly with our player. So let's hit create and let's add some graphics. So Control A, we'll search for sprite and select the sprite 2D. And now we can drag in the texture we want. So let's go under our assets, sprites, and drag in the platforms.png. Let's hit F and zoom in. And as you can see, this is also a sprite sheet and it's currently just displaying all of them. So let's go in and define exactly which one we want to show. We can do this under region, enabled, and hit edit region. And so we can kind of crop out the element that we want to show. I'm going to change the snap mode here to pixel snap. And I'm just going to go for a default grass platform. That looks good. And now
can I use the snap, pixel snap, on the collisions? Yes. Half pixel snap. Oh, there we go. And now I can be very precise with that and avoid these sharp edges. Great, okay.
we close it, we can see our sprite perfectly cropped out. Again, we have the warning here, so let's go ahead and add a collision shape 2D. For the shape, I'm going to add a rectangle shape, and now we can simply click and drag this to configure it. Then let's rename our top node here to platform and save the scene, so Control S. In our scenes folder, hit save. We've actually created our platform. So in our game scene, we can drag it in, go under scenes, find the platform, drag it into wherever we'd like, and let's hit play. And as you can see, it works. However, one problem right now is that we can't actually jump onto the platform from underneath. To fix this, we turn it into a one-way platform. So in our platform scene, let's select our collision shape and enable one-way collision. And now when we play, we can jump onto platforms from underneath. However, the player is currently passing behind the platform. This is because the platform is currently after the player in the tree. This means that each frame, the player is drawn first, and then the platform is drawn on top. We could just move the player in the tree, but I don't want to depend on that. Instead, we fix the draw order by changing the z-index of the player. So in our player scene, we go under ordering and set the z-index to something higher like 5. By default, all visible nodes have a z-index of 0. Because they all have the same index, they are drawn according to their order in the tree. So by setting the z-index to a higher value, like 5, we ensure that our player will always appear on top. And now if we play, we can see that our player passes in front of the platform. So our platform is working, but it's currently just hovering there. We might want some platforms to move around to increase difficulty. So let's use animation to do that. I'm going to leave this platform here as kind of a static platform. I'm just going to place it there. Then I'm going to place another platform over here by simply dragging it in. This is the platform that I would like to move back and forth. In fact, let me just go into the tile map and make this gap even larger. There we go. So to add animation to this platform only, we simply select it, add a new node, and we want to use an animation player. Let's hit create. And now we can add a new animation. and let's name that move. Animation players in Godot are extremely powerful because they allow us to animate pretty much anything. In this case, we just want to do something really simple. We want to go to our platform and make a keyframe under transform for the position. So I'll hit the key right here and hit create.
Yeah, this
then we
is
can
cool,
go
but
forward in our
I don't
timeline
really
here
need this
to say 1
right
second.
now.
Move our platform to the right. So I'm going to click and drag. I'm also going to hold down shift to kind of snap it to one axis. Let's move it to there. And let's add another keyframe. And now we can see that if we play, the animation plays. We also want this to loop, so I'm going to select loop here. However, this is going to loop in a way that it snaps back to the original keyframe. Instead, let's press it again. And now you can see that it's going to start ping-ponging back and forth. If this is currently too fast, we can simply increase the length of our animation. So here's the length. Let's set it to 1.5 instead and drag our last keyframe to the end. And there we go. We now have a moving platform. Let's just make sure that we set it to autoplay. And now when we play the game and go to the place where we made our platform, we can see that it's moving back and forth. And if we jump onto it, the player will smoothly follow it. Really cool. And there's already so much you can do with this. Next up, pickups. Now let's add a coin that we can pick up. Again, we start by creating a new scene.
Okay, I want to skip this. Dying. Wall the building.
These nodes and categorize them. The easiest way to do this is by simply adding a new node. For this one, I'm just going to select the base node here, hit create, and now we can rename this. I'll make one for, say, coins, and simply take all of the coins and drag them under that node. We can do the same thing for platforms.
Player 2.0.
Player 2.0.
What is that?
So far, we've been using the character movement template pretty much as is. But we need to modify it in order to add animation to our player, as well as change the key bindings that we use to move. So what are we looking at here? Well, the top two lines define two constants with our speed and jump velocity. There's also a variable here that defines the gravity based on our project settings. By default, this is a value of 980. So we have these three values, but the meat of the script is really inside of this physics process function. Physics process is very similar to the process function we used for our enemy. However, while process is great for a lot of things, there is one part of the game engine that really struggles with not knowing how many times per second it is going to be run. That is the physics engine. Physics in general need to update at fixed intervals to avoid janky behavior. Luckily, physics process solves this problem because it runs at a fixed rate, 60 times per second by default. This is independent of your game's actual frame rate and helps physics run smoothly. We use it for anything that involves the physics engine, like moving something that should collide with its environment, such as a player character. So in this function, a few things are happening. If the player is not standing on a surface, we add gravity. If we press the spacebar and the player is on a surface, we jump. And then we get the direction we need to move in based on what arrow keys are pressed and move accordingly. Now let's start by rebinding some input keys. For this, Godot uses an action system. We create actions for anything we want to do in the game. Jump is an action, so is move left or move right. We can then bind keys to these actions. Let's try it out. So let's go to Project, Project Settings, Input Map. And here we can add some actions. I'm going to add a jump action, as well as a move left and a move right. Then we can use the plus sign over here to bind a key. So to my jump here, I'm going to hit plus, and then it's listening for input. So I'm going to press the space bar and hit OK. And as you can see, space is now bound to jump. For a move left, I'm going to bind the left arrow key, and I'm also going to bind the A key. So we can use VAST for movement as well. As you can see, there's no problem binding multiple keys to the same action, which is really handy. I'm also going to bind right arrow to move right, as well as the D key. And now we can use these actions in our script.
I really like this input map system.
By default, Godot uses some built-in actions that are meant for navigating UI. This is why it says things like UI accept here. Let's replace these with our own actions instead. And as you can see, it will actually help us by auto-completing here. So I'm going to put in jump for my jump action, And then for moving left here, I'm going to change to move left. And for moving right, I'm going to change to move right. And now we can use the keys bound to our actions to move around, which in my case are both the VAST keys and the arrow keys. Awesome. The next thing we need to do is to update our player graphics to face the direction we are moving in, and to play the right animation. Let's start by flipping our sprite based on direction. So just like with our enemy, we first need a reference to the animated sprite node. Again, here we can simply click and drag and hold down Control. Again, I'm going to remove the 2D from the name.
Oh, wow. Oh, wow. That's cool. Wait, what?
To make it, we can simply click and drag and hold down Control. Again, I'm going to...
So if I just drag, that just adds a reference like that. But if I want it as a property, that's Control.
Remove the 2D from the name to make it shorter. And then we'll add some extra code to our function. Now, this line here defines a variable called direction that is based on our input. If we don't press any buttons, direction will be 0. If we press move right, direction will be 1. And if we press move left, direction becomes -1. So we can use this variable to check if we are moving left or right. I'm going to make some space in the code here and make my own comments as well. So use a hashtag for a comment. This here gets the input direction, which can either be -1, 0, or 1. And this down here actually applies the movement. So in between, we can add a section that flips the sprite. To do this, we check if our direction variable is greater than 0. Well, that means we are moving to the right. And we can set animated sprite dot flip horizontally to false. If this is not the case, well, then we want to check if our direction is less than 0. For this, we can use the else if or elif keyword. So else if our direction is less than 0, well, then we'll set animated sprite dot flip age to true. And now if we play this, we can see that our player sprite indeed faces the right direction. Now let's add some animation. So let's go to 2D view, select our animated sprite, and let's add 2 new animations. One called run and one for jumping. In our run animation, I'll add some new sprite frames. Select our knight. Remember, this is 8x8, and I'll simply add all of the frames in the run animation, which stretches over 2 lines here. I'll add those frames, set the FPS to 10, and play. Looks good. Then for the jump animation, I'll also add a sprite frame. And there are a bunch of different ways to go about this. But in our case here, I think we should actually play our jump animation whenever we're just in the air. This means that this will also play when we're just falling off a platform. And for this, we could use a very quick looping animation or simply a single frame. I actually like this one from the roll animation, so I'm just going to use that. Then in our script, we can of course play these animations. So after we get the input direction and flip the sprite, let's add a new segment, which is going to play animations. And here we also need to check our direction variable. More specifically, if our direction is equal to 0, well, then we're standing still. And we can go ahead and play animated sprite dot play the animation called idle. If this is not the case, so else, well, then we want to play animated sprite dot play the run animation. And that's actually it. If we now start running, we can see our run animation being played. Finally, we just need to add our jump animation. And here we can use a built-in function of our character body 2D, which is to check if we are standing on the floor. So at the top here, we'll check if we're currently on the floor is on floor. Well, then we want to go ahead and play our idle or run. So I'll cut this using Control X, paste it in here, make sure you tab in. And if we are not standing on the floor, well, then we're in the air and we can go and play animated sprite.play our jump animation instead. So if we're on the floor and our direction is 0, well, then we're playing idle. If it's not 0, well, then we're playing run. And if we're not on the floor, we aren't doing any of those things. We're just playing the jump animation. And that's it. Now if we play, we have a fully animated knight. I like to think that she's a former princess who got so tired of waiting to be saved from the big bad dragon that she took matters into her own hands.
Okay, so we need to implement that a little bit differently. First of all, let's take a look at the sprites that we have. Where are the sprites? Animated sprite. There we go. That was weird. Oh, I guess I needed to click here below. So, what do we have? This is the run. This is like down, up, no. Ah. Okay, so what do we have here? We have facing the camera, standing, facing the camera, running, then facing away from the camera, standing and running, left, left running, right, right running. So, so this idle is gonna be down idle, then how do I add? Okay, new animation. That's gonna be down run. Ah, I see. So down run, same sheet, these two, FPS 2. Another one is right idle. Not idle, maybe stand. Okay, right idle. This is a weird sprite sheet. Why do we need this if we can flip? Like we don't need the bottom row. But okay, right idle. No. Let's follow the order of the sprite sheet. So the next one would be up idle. Two FPS. Up run. No, I guess it orders by the name. Okay, next. What's next? Left. Left idle. Left run. Right idle. Right run. Okay. Now we need to dynamically switch these depending on the direction by using this play function call. So input direction. So let's do if input direction dot x greater than 0, then animated sprite. No. Then we have another if. So this defines left, right. Oh, our sprite is weird as well. So, and movement is weird. So we have a completely free movement, but we need to somehow decide which sprite we're gonna use. Also, yeah, we have two states, run and idle. Idle should be when the direction is 0. Oof, this is weird. I don't like this sprite, but yeah, either way, I would need to implement something like that. So when direction x is greater than 0, that means that we are moving to the right. So it's the right sprite then, and it should be the run version because we are moving. When we are stopped though, we need to replace that. So let's start with the stop thing. So if direction x is 0, is that the correct syntax? Input direction y is also 0. Then we need to force the animate. What I can do is I can store the last direction, last sprite direction, left, right, up, down. And when we are stopping, so yeah, this is incorrect. So this indicates that we are stopped, and we need to replace our running sprite with the idle sprite. Yeah, I guess we need the last sprite, or something like last right direction string. equals down. Right. And then we just do animated sprite dot play, and we do the last sprite direction. How do we concatenate? Plus underscore idle. Then else, or elif, I guess. No, else. So if input direction x greater than 0, that means that we're moving right. So we need to set the last sprite direction right and play underscore right. No, underscore run. What's wrong with this? Ah. Else if this is less than 0, that's left. Then if y is greater than 0, y is greater than 0, that's down. And less than 0 is up. Probably it's not gonna work, but I'm curious. It does work. Let me connect my gamepad. Yeah, another thing is I need to pick the dominant direction. It should be different. Right now, movement left, right, always overrides up, down. So if I move slightly to the left and up, like, yeah, on controller, I cannot even make it straight because it's not possible to have straight 0 on the analog stick. So, it should be a little bit more intelligent. So first I need to choose which one is greater, X or Y. And that would decide, do I draw one of left-right sprites or up-down? So if absolute input direction X greater than absolute input Y, then we do this. Else we do this. So let me see. So if absolute X greater than absolute Y, That means that we are moving left to right more dominantly. Then we need to choose if it's left or right. And then if the dominant direction is Y, then yeah, should be fine. It works perfectly. It's awesome. Except I need to increase the speed. Let's add some sockets and we run all chat. Yes, definitely later. There's a reason why I started this project in compatible mode. I'm gonna make it a WebASM or WASM program. So what do they want to... animation. No. Sprite frames. Okay, so idle animation is 2 FPS. The run should be faster. How do I play it? Hello? Oh, I guess I need this scene. So run should be maybe 10 FPS. Let's try 10 FPS. It looks funny. It's a little bit weird. Maybe it can be even faster. No, now this is too much. Oh, maybe I can even adjust the animation rate based on the speed. Because on the controller I can move really slowly. Speed scale. Ha. Let's see. Script. So this is we are moving. So while staying here, we need the length of the input direction vector. Length. Why didn't it... okay, so we have the length. This is gonna be our scale. And this is from 0 to 1. And we should be able to do animated sprite. Speed scale equals that thing. Yes! We can now run slowly and faster and faster. Probably 20 FPS is a little bit too much. Let's try 12. It didn't save. You know what? 12 is a little bit too much. Maybe. I mean, 12 is a little bit too low. So maybe 15. If not, we're gonna go back to 20. Oh, this is fine. 15 FPS, I guess. Okay, so we have that. Also, I want to move the player's default position to somewhere. Somewhere there. Yes, good. Okay, I like this. Can we make the jumping animation? Or... I don't even know. I want to have a jump, but I'm not sure how it should behave gameplay-wise. I don't think I want to have the player be able to jump on top of the hills. But I want the jump to be like a graphical feature, I guess. Yeah, that's gonna be like going against the engine a little bit. I would have to calculate my own jump velocity. Because I don't want to update the actual velocity, or... Right now our player has the actual... Wait, slide. I see. So by default they set the velocity to gravity times delta, which basically pulls the player down. And this is actually a constant speed, I think. No. They update the velocity. Okay, I see. I see. But this is not suitable for us because we are technically floating in the air with this kind of game. We're floating in the game. Because if we would stand here, that would count as also... Probably need to stop the animation when we are blocked. Maybe not. I don't know. What was I doing? So yeah, technically we are floating in the air. In the air, gravity is not applying to us in this game mode. And to have jumps, why is the animation not playing right now? Weird. Sometimes the animation doesn't play. Really weird. We have the animated sprite play for every case, I believe. Ah, I know why. Because we had the scale. We need to reset the scale to 1 here. Yes, that was the problem. There we go. So for jumping, I want, I guess, the sprite offset to change over time. So if we press jump, we need to go up and down a little bit. So this is going to be our jump velocity. And where was that input? This one. So we don't need the is on floor. I do need the jump velocity, but this is going to be our own. No, wait. Jump velocity. We're going to add another constant. So when we press the button, and wait, not this one. And jump velocity equals 0. Then we set it to initial velocity. Then then we do the same here. But this is only if we are not on floor, right? Boof. And our on floor is offset 0 of the sprite. Ah. So this is essentially what we had for our platformer. We're recreating here, but we're using sprite offset and our separate jump velocity. So if we're not on floor, we add the gravity, right? If we're not on floor, which means offset is less than 0, because this is an inverted axis. That's stupid. Okay, so if y is greater than 0, well, less than 0, we apply gravity to jump velocity. Then if we click accept and our offset greater than 0, greater or equals than 0, this is float. Okay, perfect. Then we set the initial jump velocity, like here. But we also need to apply the velocity to the offset, which is offset y plus equals jump velocity times delta, hopefully. This is gonna be something weird. And it actually almost works. It almost works. I just need to stop when I'm on the ground. If this offset No. We need to do it here. So if offset y is greater than 0, then we apply this. Else, we reset it to 0. Doesn't work. It's the inverted axis. No. What did they do wrong? So if offset greater than 0, no wait, yeah, greater than 0, then we reset it to 0. And the velocity, I guess, needs to it actually works. Purely visual jump. We just need to make it smaller. Good night, 𝙽𝙴𝚂. Thanks for stopping by. So initial jump velocity gonna be 100 maybe? Maybe a little bit more. 150. Just a little bit lower, 140. This is purely visual, but it's fun. I don't know. And maybe we can jump off cliffs if we are in the jump position. I don't know. We'll see later. Okay, this is already pretty good. Probably need to group this a little better. Okay. Now this is sprite animation. And this is purely visual jump. Okay. The default one will stay there for now, so I can peek into the implementation. I want to have a shadow. That's another thing that makes the jump a little bit less obvious. I just need to have a shadow underneath the character. Should I just add a sprite for the shadow? What's wrong with this tile map? Tile map node is deprecated. It is superseded by the use of multiple tile map layer nodes. Convert tile map to set of tile map layer nodes. Open the tile map bottom panel with the node selected. Tile map, yeah. Click the toolbox icon in the top right corner and choose Extract Tile Map Layers as an individual tile map layer nodes. Now I guess I just add an empty node node, tile map, just node, and I move these things there. Is that correct? I guess so. Maybe the speed is a little bit too high, but it's okay. This is so weird that these tabs don't affect the actual code editor. It's a little bit counterintuitive. But okay, I think for now, this is a good progress. We're gonna continue next time. But so far, I'm enjoying actually working with Godot. Godot script is weird, but whatever. So yeah, I guess this is gonna be it for today. We're gonna continue next time. Let's see. Do we have anybody to raid? Let's see, who is this? Oh, I like this stream already. So let's rate this person. Oh, sick. I wanted to do something while I do that. Okay. So, this is gonna be it for today. So far, good progress. So far, Godot is fine to me. Like, it's a little bit weird, but I'm enjoying it. I like it. Yeah, we'll continue next time. I'm not sure when exactly. Probably next Sunday we will continue with this particular project, because I will most likely work on Emirheim during the weekdays. Not sure, we will see. Or maybe we will continue with this if I am feeling like it. But yeah, there's a lot of stuff that I still want to implement here and play with Godot. Like, I want to make this, export this as a web project, and I want to maybe add some multiplayer. We will see. But yeah, so far looks good. So yeah, thank you everybody for watching. Hope to see you next time and have a nice day. Bye bye.
Don't tell me you're following me. Follow